Let's go. Have fun.
Good afternoon, everybody. My name is Sarah Gibson, and I'm a senior robotics engineer at Qualcomm. The video that you just saw was highlighting some of our recent achievements in state-of-the-art drone technology, which we showcased at CES last month in Las Vegas. And I'm going to explain some of those technical details in a bit, but before I do, I just want to say a few words about Qualcomm in case there's anyone here who is not that familiar with the company. So we're one of the biggest chip makers for smartphones, and our flagship processor, Snapdragon, can be found in millions of devices worldwide. Our roots trace back to the early days of digital wireless comm. We pioneered CDMA technology in the late 80s and early 90s, and ever since then, we've been the technology leader in 3G, 4G, and now 5G. I myself work for Qualcomm Research, which is the center for innovation in the company. And we focus on developing new technologies from the next generation of wireless to semiconductors to IoT and robotics. And typically we focus on technologies that are about 3 years out from commercialization. But from a robotics standpoint, we already have a development board called Snapdragon Flight. And it has Wi-Fi and GPS integrated, along with the Snapdragon 801 processor, which is the same processor found in many of today's smartphones. And it's all in a very small form factor. It weighs only 12 grams. So since we've combined all of these capabilities onto one single board, we can enable smaller, lighter, and smarter drones with better battery life. And we can achieve similar flight performance to drones in the $1,000 plus range, for less than $300 at retail and still supporting 4K imaging. In addition to the Snapdragon Flight hardware solution, we also offer an advanced flight control software package called Snapdragon Navigator. And it was optimized to run on a Snapdragon chipset. The flight controller runs on an isolated DSP to provide real-time, low-latency access to I/O, and it can provide 500 Hz attitude updates for smooth and stable flight. It also performs a lot of the sensor fusion using measurements from the IMU, sonar, barometer, and GPS to give you a really accurate pose estimate so that we can get that really stable control. And it includes some advanced safety features like propeller obstruction detection to provide the user with the safest experience possible. So in a minute, I'm going to show you another video, this one of our autonomous visual navigation demo, which we showed at CES in 2016, which was over a year ago. But first, I want to highlight a few of the technical components that you'll be seeing in that video. So one key piece of technology that we have, which you also saw in that opening video, is our location tracking software. And you might be thinking, why don't you just use GPS to track the location of the drones, just like I do in my car when I'm navigating? And that's a really great question. Our drone platforms do include GPS for outdoor navigation, but GPS typically doesn't work very well indoors, and even if it does, the precision is typically on the order of about a meter, which isn't good enough to fly those really complex routes through crowded environments like you saw in the opening video. So here, our drones are relying on machine vision to keep track of their precise position and orientation. Specifically, they're using an algorithm called visual inertial odometry, or VIO, which tracks the position of the drone by fusing IMU measurements, which is the inertial sensors like gyro and accelerometer, with the downward-facing camera, which is being used to track visual feature points on the ground beneath the drone. And I also want to point out that oftentimes when you see autonomous drone demos, they're relying on motion capture systems, which track the position of the drone using dozens of cameras placed around the perimeter of the flying area. But that's not what we're doing here. Here, all of the localization is happening on the drone itself, all on the Snapdragon processor without any additional specialized hardware. Okay, so in addition to that downward-facing camera, we also have a pair of stereo cameras on the drone. And we use those to compute a depth map. And the depth map gives the drone a sense of how close it is to obstacles in the field. So you can think of the depth map like an image, just like a snapshot from a camera. And for each of those depth images, we also have a corresponding pose of the camera when that image was taken. And again, we're getting that pose from VIO, so it's super precise and super accurate. So we can fuse that data together to create a 3D map of the world. And that 3D map gives the drone an understanding of the structure of its environment, like where obstacles are that it needs to avoid. And once we have that 3D map, we can do some really cool things, like prevent the pilot from flying into obstacles. And we can also use the map to generate path plans that the drone can follow autonomously, which is what you're going to be seeing in this next video. Okay, so in this video, there's three panes. The upper left pane is showing you a view from the first-person 4K camera, which is a fourth camera that this drone has in addition to the three I mentioned earlier. The bottom left pane is just showing the view from a camera that's mounted inside the flying area, which is just giving you a different perspective. But the really cool part is happening on the right side of the screen. And this is showing you a visualization of the 3D map that the drone is building on board in real time using its depth from stereo data. Okay, so the first thing that you're going to see is the pilot, which in this case is actually me, take off manually using a tablet interface, which unfortunately you can't see in this video. But I pressed a button to take off. Now I'm going to be flying around manually, and you can see that as I fly, that 3D map is being updated in real time to reconstruct the environment. So you can see the back wall has come in nicely, the floor is coming in, and then as I fly to the left, you can see the arch structure coming in. The next thing that you're going to see me do is basically drop a pin in my location. So I'm going to tell the drone to store this location in memory as like the home location. And then I'm going to fly the drone around manually some more. And I'm really going to test whether this obstacle avoidance software works. So right now I'm going to try to fly right into that arch structure. And you're going to see that the obstacle avoidance software running on board tells me, I'm not going to let you do that. And you can see some of those status messages being printed in the upper left of the screen. So I'm going to try one more time, back it up, boom, no, doesn't let me. So now I'm going to try to run into that back wall at full speed, and you can see that the obstacle avoidance software slows me down and then stops. Okay, so now I'm done playing around. I want to tell the drone to go home, go to that stored location. And so I press a button on my tablet saying navigate. And what you'll see is the drone switches to autonomous mode, automatically plans a safe collision-free path through its environment, and executes the path autonomously. And notice that it's taking a different path through the environment than I originally flew it in. So it's not just memorizing the path that the user flew it in. Now we're able to run all of these complex operations on one small board, just on one chip, because of our heterogeneous compute design, which lets us distribute different processing components over the CPU, GPU, and DSP. So in this example, like I said, the flight controller is running on the DSP. Some of the machine vision aspects are running on the GPU, and the map building and path planning are all running on the CPU. Now, since we are Qualcomm, the obvious next step would be to enable non-line of sight operation using 4G LTE networking, which is what we're actively working on now. And we believe that once we add in 5G on top of that, there's virtually no end to what these drones will be able to do. Thank you.